Chuck here again. Still working on this high-speed machine. So I was going to test out the the lamp matrix, and I ended up buying from DigiKey one of these little 8x8 LED matrix units, which I was going to build. Hopefully, I'll show you up here. The little test boards that like Pinball Life sells. Pinball Life sells them for I think $26 or something, and then you got to pay shipping, and it takes forever. These DigiKey ones are $8 a pop, and free shipping if you have a big enough order, which I did. So I had to laugh because I bought this matrix, and then I'm looking at the data sheet, and it this thing comes in a common cathode and a common anode version. And I'm thinking, oh my God, I probably bought the wrong one. But then I determined that, okay, if this is common cathode, then this is common anode. So not a worry. So I don't know why they actually have two different versions of this. That's really, really silly, but I was kind of kicking myself for that one. Anyway, I'm going to go put this onto a breadboard and use some insulation displacement connectors to plug into the high speed and put a few current limiting resistors on it, and then I should have essentially a test board. So I don't know. Since my time is worth nothing since I'm retired, I think building a test board's, it's a little bit cheaper than buying one, and more timely since I have this thing in hand. Back shortly. Okay, here is the 8x8 lead matrix wired up to the 9 position IDC connectors. Yeah, the wiring on this thing is very strange, but I tested it out and it works like it's supposed to. All right, so this time I've hooked 12 volts up to the lamp matrix power supply and got our test circuit in. So if I hit the CPU test button now, and we see that we've got the lamp matrix is actually doing its thing. And for the most part, it looks okay. It looks like we've got one of the channels is perhaps out. So I'm gonna throw a scope on here and see what's going on. Also, it looks like the top 3 channels are the same. I don't know. I mean, hard to tell just by looking at this. But that might be completely normal, or things might be shorted together. It's hard to say. But I'll be scoping out the signals and figuring out what's going on, and we'll see what's up with that missing row. Maybe it's supposed to be out, or maybe something's gone along the way. So here is the scope. I'm going to first scope the that socketed 7408. I should have the schematic up here for you to follow along with. So on the bottom, NAND gate on U52, output on pin 8. There we can see a nice looking strobe output. And the next one is pin 11. That also looks nice. Pin 8 actually doesn't look nice because that's got 4 volts on it, so something is going down there. Pin 6 is okay. And pin 3 looks okay. So the next one, U53, pin 6. We've got nothing, so that's the blank or burnt out row on the switch matrix. Pin 3, that's on all the time, so that makes sense. That's the bright, one of the bright rows. pin 8. Pin 8's on all the time. We got 8 volts on that. Again, not good. Probably a leaky Darlington. And pin 11. And again, that's on all the time. So the outputs that are on all the time explain those burnt power resistors, the 27 ohm, 5 watt power resistors. So that would be R89, R88, and R87. And there's obviously some questionable the Darlingtons there for sure. I think Q63 is toast, and I imagine Q51 as well. So I guess it's back to DigiKey to get some more replacement parts, and I'll pull some of these transistors out of the circuit board probably tomorrow and test them out and find out which ones are good and which ones need to be replaced. But I think on the right side, the lamp return circuitry, that seems fine. So if I get this under control, that'll take care of the scorched area on the circuit board. Maybe that's a good way to approach these repair jobs, is look for the burnt stuff and fix it. Anyway, thanks for watching. Until next time.